This is the second part of the video. We're going to find the refractive index of the outside of the block now. What I've got on the block is, as before, I've got a line marking the centre, but on the back of it I've got a piece of paper with a line drawn on. Now what we're going to do with that is look from the inside of the block when I've got this in the right position, and we're going to basically stick this down with different liquids, and by sticking it down with different liquids we're going to be able to find out the refractive index of the liquid. It can be microscopically thin, but it will still work. So effectively what we're doing is the light here will refract off from here, so we're actually going to look in here, but we're going to look at the point. We can't see refraction along the surface, but we can see when light coming in from this side reflects off. So we're going to find the point at which we reach a critical angle, and that critical angle is the point at which the light starts to reflect off the inside rather than some of it coming in along the straight edge. So if I lower it down here, you can see our line quite clearly through, and this will change. I'm going to dodge a little bit, but as you move around, what you'll see, there we go, the paper with the line on has disappeared, and that's because we've gone past that critical point. So if I go back, we can get to the point at which that line there just disappears, and what we're going to do is just double check it. Yeah, that's still just there. So I'm going to place the pins just in line with that and stick it down into the base again, and again line it all up, and when they're in line then we know the ray must be coming straight past those two pins in a line along here. So from above, again, I can mark that ray. Looking at above, even at a first glance, you can see that's around about 45 degrees, but we'll measure that later. I'm going to put a little bit of a marking on here, and what we've got between the paper and here is just air. So actually these are both just going to be the pins for air on the outside of the block. Now what I've got is, I've got two other substances. We have oil in here, we have water in here, and what I'm going to do is I'm going to stick them down with water. Simply take my next piece of paper and I'm going to just dip it in the water. So it may not look much, but you've now, when I've got that stuck on, it's going to be stuck on with a layer of water, very thin layer of water on the back of the block. So I will just put that back in there while I remove the last piece. Okay, so I've got that piece of paper stuck on now, this time with water. There's our position that we had before, and actually you can see if I slide it round it goes much further before the line disappears. So if I get it just so it's just on the line disappearing, again what I can do is I can put in these so they line up exactly with it, and again with parallax, if I could move, if this was the practical, I'd move my head from side to side to make sure they were lining up, but you can see they actually go in a nice straight line, because if I look to the side now, they're not in line. Okay, so that angle there is due to the refractive index of the water. Look how much difference there is from the oil. It's a long way around. Why? Because the water is much thicker. Now that last one looked like the block had moved, but actually I moved in my hands after I'd stuck everything down and got the pins in place. Just double checked it. So here we have the oily surface on the paper, and again what I'm going to do is try and put it on so it sticks on and lines up with the line on the block. You can see how it changed colour with the oil there being squeezed in. So we've got oil, just normal garden and veg type oil, and we're going to take that and put that on the position there. Okay, so there's our lines for the air, and the paper was held on with air. The line is still very visible, so is the whole of the yellow post-it. If I go round, that's now lined up for where the water was, and again you can still see to the left here, you can still see the paper, so we need to go further. And you can see the line there. Unfortunately it's quite an angle now, so it's going to be quite hard to actually find this with any accuracy, but around about there is the line. So I'm going to move the whole thing again accidentally, so let's just try that again. So there we go, and I'm going to put in to line up with that there. It's the bottom of the pins that matter, because that's where the hole in the paper is going to be. Let's say there. Okay, so very different angles. One ray there for air, one ray for water, one ray for oil, and what I'm going to do is measure them with a protractor. Okay, pins are out. Let's take away the block. I need to make a bit of a line there, but it doesn't matter because this is semicircular. We know that because that's in the centre, these will always point directly to the centre. So what I can do is be a little bit lazy here, and yeah, nice and oily. If I put this, so the 90-degree line is actually on the flat surface, what I'll find is that 0 is your normal, and then we can actually measure everything across. So I'm just going to draw in the lines from the dots that you can probably just about see in the paper, and then we can take it from there. Okay, with our lines drawn on, you can see the angle for air is 41 degrees for perspex into air. Let's just write that on, so 41 degrees. For the water we have 62.5, so 62.5, and for oil that leads looks to me like 81.5, so 81.5. okay, so those are your three angles. You can use our equation, of course. nu1 sine theta 1 equals nu2 sine theta 2, and doesn't matter if whichever we take, but we've already found the refractive index for the perspex. We know the angle in the perspex because it's there for the three different substances. The refractive index on the outside is the liquid or air, so that's your air, water or oil, and that's the angle at which it disappears, and the point at which you get reflection is where you've just gone beyond 90 degrees there, unmeasurably beyond. So this is sine of 90, which of course 90 degrees, which is of course equal to 1. Okay, so do the maths and you can find out from our refractive index of the perspex, you can find out the refractive indices of the air, the water and the oil. Okay, brilliant.